Welcome for this wonderful session. The difference between saturated and unsaturated polymers lies in their chemical structure, specifically in the types of chemical bonds present in the polymer chains. Saturated polymers. Definition: saturated polymers are those in which all the carbon atoms in the polymer chain are bonded to 4 other atoms, usually hydrogen. As a result, there are no double or triple bonds between carbon atoms in the chain. Properties: saturated polymers are generally more stable, less reactive, and have higher melting points than unsaturated polymers. They are also less flexible, making them more brittle. Examples of saturated polymers include polyethylene and polypropylene. Subscribe our channel. Press notification bell. Like, comment and share this video with your friends and family. Unsaturated polymers. Definition: unsaturated polymers are those in which some of the carbon atoms in the polymer chain are double bonded to other carbon atoms. As a result, they have fewer hydrogen atoms bonded to the carbon atoms in the chain. Properties: unsaturated polymers are generally more reactive, less stable, and have lower melting points than saturated polymers. They are also more flexible and have higher elasticity. Examples of unsaturated polymers include polybutadiene and polyisoprene. In summary, the main difference between saturated and unsaturated polymers lies in the presence or absence of double bonds between carbon atoms in the polymer chain. Saturated polymers have no double bonds and are more stable, less reactive, and less flexible. Unsaturated polymers have double bonds and are more reactive, less stable, and more flexible.
Welcome to the wonderful session. The main difference between polar and nonpolar polymers is the presence or absence of polar functional groups in their molecular structure. Polar polymers. Definition: polar polymers are those in which the molecular structure contains polar functional groups such as hydroxyl, O, carbonyl, greater than C equals O, carboxyl, Co, or amino, N.H. 2 groups. Properties: polar polymers have a permanent dipole moment due to the uneven distribution of electrons in the polar functional groups, which makes them more hydrophilic, water-loving, and capable of forming hydrogen bonds with other polar molecules. They also have a higher surface energy and are more likely to adhere to surfaces. Examples of polar polymers include polyvinyl alcohol, PVA, polyacrylamide, and polyethylene oxide, PEO. Subscribe our channel. Press notification bell. Like, comment and share this video with your friends and family. For better understanding, please watch the video until end. Nonpolar polymers. Definition: nonpolar polymers are those in which the molecular structure lacks polar functional groups and is composed of only nonpolar bonds such as carbon-carbon, CC, and carbon-hydrogen, CH, bonds. Properties: nonpolar polymers do not have a permanent dipole moment and are more hydrophobic, water-repelling, due to their inability to form hydrogen bonds with polar molecules. They also have a lower surface energy and are less likely to adhere to surfaces. Examples of nonpolar polymers include polyethylene, polypropylene, and polytetrafluoroethylene, PTFE. In summary, the main difference between polar and nonpolar polymers lies in the presence or absence of polar functional groups in their molecular structure. Polar polymers have polar functional groups and are more hydrophilic, while nonpolar polymers lack polar functional groups and are more hydrophobic. Thanks for watching.